All right, guys. So this is my day two documentary. So in my day two, I actually created a clean architecture for my Node.js backend app. So my fintech system design, I actually created a very clean architecture that can make it very scalable. It's easy to scale. It's easy to maintain and stuff like that. So welcome back, everybody, to day two of building a production grade fintech backend system from scratch. So I'll be walking you through on all the things I did. So in today's video, we are going to set up the architectural foundation of the backend using a clean architecture principle. All right, so using clean architecture principles. So with this now, it is going to help us structure our project, our system, our project very well. So now, before we start building authentication, before we start writing any code at all, before we start writing any code or implementing any feature at all, we need to structure. We need a structure that can actually scale and remain maintainable as the application grows. Whether you like it or not, your application will definitely grow. I told you the Global Genius, where my online learning platform. When I was building it at the time, it was so difficult. I was no longer understanding what I was doing because it was going bigger and the structure was not clean. The architecture was not clean. So today I'm going to show you what a clean architecture is, why does it matter, how to structure your backend properly, and then how to separate your business logic from how to implement entities, repositories, and use case step by step. Okay. So why clean architecture? Why do you need clean architecture? One mistake that we developers make is when we are building backend applications is missing everything together. Even your front-end application too. Your front-end application should also be very, very structured. All right. Now, for example, database logic can be, some of us put our database logic in our controllers. So let me show you something. Let me go to my code. Let me go to my, this is my controller. So let's assume now, let me go to my forgot password controller. You're going to see now that there's nothing like, look at it, there's nothing like connecting to the database here. Look at it. What I'm doing here is that I'm only getting the data from the body and I'm doing some checks here. And then this is what connects, this is what is actually connecting to my database. So I'm using a use case that you're going to see. I'm going to show you how I did it. I'm using a use case, and then I'm with this execute method is actually going to handle from here. I will go to the application layer, and from the application layer, I will talk to the infrastructure layer, and then talk to the database. You can see how clean and very simple it is. It is not clustered. Okay, so that is it. Business logic inside routes. I cannot put business logic inside that. So let me also show you my routes. My routes, look at my routes. So this is my alt route. So you can see it. I don't have any business logic here. I don't have any business logic here at all. Look at my routes. I do not have any business logic. There's no business logic here. All right, so my route is actually talking to my controllers, okay? So validation is scattered everywhere. No, we only do validation in a particular place. Our validation should be done in a particular place, and it's actually in our domain layer. Now, even if you take a look at what I did here, you can even see that somehow my clean architecture is not even perfect because, I was in a hurry trying to make something work, and I had to scatter so many things here. This application, I should only have application, domain, and infrastructure. Every other thing should be inside of this application or stuff like this. So, but the thing is that I'm going to refactor it, all right? But what I'm trying to preach here is good, clean architecture. Your validation should not be scattered everywhere. They should only be, a particular place. Your business logic should not be inside your route. Your database logic should not be inside your controller. That Prisma, you cannot be calling Prisma calls direct from the entire application. It should have a particular place you're calling your Prisma from. Okay. So now, at first, this feels fast. When you try to do all these things, just like I'm showing you now, I was just trying to speed up. I'm somehow, I didn't even follow the clean architecture. I didn't even follow the clean architecture that I started with. So somehow, some of the things were scattered here. But of course, I'm still going to refactor my code to make them good. And now, because of the structure I already have, it will be easier for me with TypeScript and with other structures that I have in place. It will be easier for me to figure out in case I refactor. If my code breaks, I can actually I can run my test and make sure that my test works. So it's going to be easy to refactor. All right. So that is the essence of. So, but if you're doing with task-driven architecture, it seems fast. But as the application grows, you will find it difficult. Debugging becomes very difficult. Testing becomes harder. Refactoring becomes risky, and the code base becomes messy very quickly. So that's why clean architecture exists. You should structure your application in a very clean way. So clean architecture is just is simply a way of organizing your application so that responsibilities will be separated properly. So you're separating concerns. There's something we call separation of concerns. You're having you have in your application, you're organizing your application based on the responsibilities they are going to carry. Okay. So the goal here is maintainability. Guys, when we talk about maintainability, is real. I'm telling you, even as I am building this application now, I started having some issues about maintainability. So that is why I'm going to refactor all these things. I'm going to refactor them. I'm going to refactor them, okay? So that maintainability will be easy, scalability will be easy because application will definitely grow. All right, testability will be there, easy, and then it will also be flexible. So you can actually change some things. You can change your technology stack. I can say, oh, I don't want to use MongoDB again. I want to use Postgres. Oh, I don't want to use Prisma again. I want to use another ORM. Do you understand? So things like that can just happen. So the most important idea here is that your business logic should not depend on any framework or database. There should be decoupling. Your business logic should just talk about business logic. It should not talk to your database. It should not talk to any framework. Okay? Instead, your frameworks and your database should depend on your business logic. Your business logic should not depend on your frameworks or databases. Your framework should and your database should depend on your business logic. Okay? So this is the project structure. So the first thing I did was to have this major 3 layers. But you can see now that because of I was trying to do something fast, I have scattered my code. So the thing is that I am going to take every single thing back. Do you understand? These interfaces are going to go into infrastructure. My routes are going to go into infrastructure. Services will be inside infrastructures. Even my controller sits between my use case and my okay. So my controller should be in the infrastructure too. So I'm going to restructure all these things. Okay. So now let's explain them. So your domain layer, what should be in your domain layer? Your domain layer should contain your core business concepts, the core business concept of the application, your entities, your business rules, your validation, your domain logic, your domain contracts. Okay. So basically, domain contracts, yeah, interfaces could also be there. Yes, sorry. My interfaces should be in my domain. It's my repository that are supposed to be. Look at, I'm just showing you the mistake I also make. So my interfaces, all right, my interfaces should be inside of my domain, and my repositories that I put in the domain should be in the infrastructure. So I'm going to restructure all these things, okay? So this layer should not know anything about Express.js or Fastify or anything you're using. Should not know anything about MongoDB. Should not know anything about Prisma. Nothing about APIs. It should just be pure business logic. Why? Because your business logic should survive even if your technology changes later. So tomorrow, if I say, oh, I don't want to use Express.js again, I want to use Fastify, my business logic will not be affected. I only have to go to the infrastructure. That's where I will make those changes. Okay, so now entity class, I created an entity class so that the entity class is going to be like a base class for all my entities. You know, when you're building or using object-oriented when you're using object-oriented programming paradigm, you are actually dealing with entities. So your users, your wallet, your transactions, all these things are all entities. So I have to create a base class so that every other thing can inherit from there. So most times entities have some things in common. At least they will have an ID, an ID in common. They will have maybe created a couple of things like that. They should have them in common. So for example, later on, entities like users, your account transaction wallet. These are entities. So they can actually extend from the base entity. So this is although even what I was preaching, because I was just, so these are my entities. So this is my base class entity. So this is my base class entity, and look at this, my user entity actually inherited from it. You can see it, although I renamed it to DB user entity, so it inherited from it. Do you understand? So this is the base class I created. I created the base entity as simple as this, and then other entities inherit from it. So the reason for this is because entities usually share common behavior, like their IDs, their timestamps, their equality checks, their validation rules. This is where I'm supposed to do all those things. Although if you take a look at my entity, I didn't do much of that here. But if you take a look at all this, most of the things I did here. So it is about that's even wrong because I'm still trying to master and get this thing to be to be something I do always. So, but this is how it should be. It should work. Okay. Now, instead of rewriting that logic everywhere, I should centralize it in my entity base class. All right. So all those things that entities have in common, they should actually be in the entity base class. All right. So this layer contains, now the application layer is the next thing. So let me show you my application layer. Application layer, this is the application layer. Okay, you see, look at me. I have interfaces here. So look at me. I was even scattering everything here. So, but like I said, I'm going to restructure it. I'm going to refactor. So this is my use cases. These are my use cases. So what are use cases? Use cases are actions that users perform in your application. A use case could be a user can register, a user can log in, a user can transfer funds, a user can change password. So these are use cases. These are actions. Login entity, login user I have the login user case, payment user case, use case, and stuff like that. So in the application layer, that's where you have your use cases. A use case represents a single action or business operation in the system. So in your application layer is where you now have to do anything that happens in your application, anything that happens in your app, they should be in your application layer. So creating a user, logging a user, transfer funds, the application layer coordinates behavior between the domain and infrastructure layer. So the application layer is the connection between the domain. Domain contains your entities, your business logic, your validation rules. Your infrastructures contain your tools, all right? Your tools and stuff like that. So your application layer actually coordinates between the domain and infrastructure layers. So the use case interface, I created a use case interface that every other use case would inherit. So if you come here, you see that, okay, so look at this API key use case. It's inheriting from this use case. And then if I go to definition, you can see where I created it. It has a single function. So this is an interface. It has a single function. And this is the input, this is the contract here. Anybody, any use case implementing this must have this thing. So to give us the input and the output, and the input are the data structure is going to take in, and the output is the data structure it to give us. So let's assume now create wallet. Now you can see now the create wallet use case implements this use case interface, and the input entity is create wallet. So that is what we have here, the create wallet. Where is it again? Okay, so you can see, look at, I made this mistake here. So the moment I do this, I'm going to change this thing to create wallet. Okay, so you can see I'm even confused right now. My create wallet, this is okay. Okay, so this input is okay. So this input is going to be of type create wallet, I think. So it's going to be of type create wallet. All right. So if there's any error, TypeScript will flag it for me right away. So it seems like there is no error. All right. So any input I give this execute function must have user ID and currency. So I'm using this. I'm using this create wallet.create to actually because there's some validations in this script, so that I'm not going to go there now. I'm not explaining the code, I'm just explaining the structure I have here. Okay, now this creates consistency across my entire application. Every use case must implement this interface. All right, they must follow the same execution pattern because I could say, okay, now let me show you one example of this. Now, this is one of the things I didn't also practice. So let's assume now that, okay, let me go to my, okay, let's go to my controllers. If I go to my controller, forget password is making use of this use case. It's making use of send reset password use case. Now, what I could do, this is tight coupling. I shouldn't even do this. It's not even showing the dependency inversion that I'm practicing here. So what I should do is that I should use case. It should be use case. And once it is use case, it's of type use case, although it's expecting now, it's asking me for the input and the output. Okay. So I could also provide it here, or I could let's assume I give any. All right. But okay, let me go back and see this send request. Does it even? Okay, so it takes in a string and returns this. So let me just copy this. So now the thing is that any, where is my? So if I go back, where am I? Okay. So the thing is that if I am when I'm now using my dependency injection to inject this particular variable, this particular parameter argument for my constructor, if it doesn't match this contract, it will flag it as an error. So I could actually still delete this one. I'm no longer using it. All right. So you can see there is no error here. You can see there is no error so far. So the thing is that this my use case has this execute. So once whatever now when I'm trying to implement it, the forgot password controller. So if I go to the forgot password controller, okay, this is it here. Where did I even call it? If I go to my routes, I don't want this video to be too long, but it seems like so if I come to my route, I think it's in the out route. If I come to forgot password controller, um, okay, so now this is the forgot password controller. So you can see now that I am actually passing. Now this is my dependency injection, my container. So you can see now that I actually passed in a different type from apart from the that's not the same thing with the use case. But the thing is that it is taking it and there's no error because this my send password implement the execute function. So, but that would be something. So you can see this is the reason why we should organize our code and have a very good engineering principle to follow. So that makes the code base easier to understand, easier to test, and easier to maintain. All right. So infrastructure layer contains external implementation. So anything that is not in our business logic and it is not in our application, our database, our Prisma repositories, external APIs, our Redis, our queues, our login system, they should be in the infrastructure. All right. Basically, anything that is external to the business itself should be in the infrastructure layer. So the repository pattern, one very important thing I implemented on day 2 is the repository pattern. So I will show you, although at the time, I actually didn't follow it religiously. Okay, so now let me show you my repositories. It's not even supposed to be, but this is my base repository. Oh, it's not even here. You can see I scattered everything, which is very bad. So you can see I'm looking for it now. So, but I think I have it. So my repository should be, oh my God. Okay, you can see you can see what I'm talking about. So, oh my God, where did I keep my repositories? It's not here. It can't be here. I have my repository. I have a base repository. I have a base repository. Okay, I think I know where. Okay, so that is one of the mistakes I also made. So I have it in my shared, and in my shared I have my types, which is this is not where I'm supposed to bring this thing. So I believe I have my repository around here. But this is very wrong of me. I was just trying to get things running. So this is my repository. Let me go to it. So this is my base repository. It has create and find ID. So I implemented it, and the repository acts as an abstraction between the application and the database. So instead of me talking to the database directly, I will use the repository to talk to the database. So anywhere I'm going to say update user, find user, create user, something like that, it should be done in the repositories. Okay, so without repositories, your business logic becomes tightly coupled to your database or ORM. So what if tomorrow you change your business, your database? What if tomorrow you change your ORM? What now happens? So your business logic, your domain layer should not be tightly coupled with your databases. So for example, imagine the Prisma changes. I'm using Prisma. Imagine I change the Prisma or I migrate from MongoDB to Postgres SQL. So if I do this with this kind of structure I have, it will not affect it. But if I do not structure it very well, it will affect it. So if your entire business logic directly depends on Prisma, refactoring becomes painful. Okay, so my business logic does not depend on Prisma at all. It doesn't. Okay, so but with repository, your application only depends on contrast. So let me show you some of the repositories I have. So okay, so now let me show you this my transaction. Okay, let me show you my user repository. Okay, so this is the repository I use to get my user. So if I want to update any user, it's in this repository. I want to create a user. I want to find user by ID. You can see here, this is where I'm directly talking to my Prisma or to my database. This is where I'm directly talking to my Prisma or my database. So if I want to make use of this, so in anywhere I want to make use of this, I will just use this repository. I'm not going to write this thing in my controller or in my application. Okay. So dependency inversion, there's something we call, although I'll still talk about it later on because I have a particular day where I designed the dependency inversion, but I think I will just have to leave it. So, but let me show you what the dependency injection really is. So if I go back to my, where is it called again? I think in my routes, yes. In my routes, you can see, look at what I'm doing here. Look at this. This is my forgot password controller. If I go to my forgot password controller, you can see that it is actually it uses this use case. Now you can see now that I did not provide any particular use case here. If I have done that, that will be tight coupling. So tomorrow, I might just want to change tomorrow, if I change my business logic or anything, all right, and I still provide anything that has this execute that implements this use case contract, everything will be okay. So if I go to my route, if I go back to my route, you can see now that I'm getting this thing from my dependency injector. So look at it. I registered it in the dependency container, and then I'm using the same password use case. If I mistakenly use any other one, it will still work because now I can change this logic. I can just change, oh, I don't want to use this particular one. I want to use another one. So this is basically what we mean by dependency injection. Helps us to make our code not to be tightly coupled. Don't worry, we'll learn more about that as we go on. All right, so testing session. So before implementing behavior, I wrote the test first. So if I go to my test in my entities, I wrote test for my entity. So if I go to test, my domain, my entities, my repository. So this is my entity test. I wrote the test, all right, and they're all passed. So I wrote the test, then I now implemented the entity itself. So this helps in several ways. Say, if I go and make changes now and come back and run my test, if my test does not pass, that means something is wrong. But if my test passes, I'll be okay. Better design, fewer regression, and more confidence when changing code later. You'll be sure that your test will actually get your back. Okay. So important lesson. One thing I want beginners to understand is good architecture is not about creating many folders. It is about separating responsibility properly. You should separate your business logic, your entities, everything. They should be in your domain layer. Anything that has to do with your main application, your use cases and stuff like that should be in your application layer, and your tools, your database, your share, whatever it is, that connects the database, that connects the domain layer and the application layer should be in your infrastructure. Okay, so a clean folder structure means nothing if your business logic is still tightly coupled. Your business logic should be loosely coupled. All right. So real-world engineering insight in real-back systems, especially fintech applications, requirements constantly evolve. You'll be changing things in your application. So you may switch your databases, you may add microservices, you may integrate a third-party provider, you may do all these things. All right, but good architecture makes those changes very manageable. All right, so what we built in day 2, so let me recap. I set up a clean architecture layer, created a base entity class, created repository interfaces, created a use case interface, separate business logic from infrastructure, and then continued using TD principles. So in the next video, in day 3, I'm going to explain exactly what I did. I will explain what I did. And if this video has helped you to understand something, maybe in your next project, you're going to structure your application well. I want you to subscribe because I'll be dropping this thing for all the days I did this. I'll be explaining everything I did, especially the engineering design principles I use. So I'll be documenting the entire process, architecture, backend engineering, testing, scalability, production. I'll be doing all these things. So I will see you in day 3. Subscribe, turn on notifications, and if you still want to learn web development, okay, I have courses for beginners, for intermediate, and for people who really want to build real applications and use it to get a job. So thank you very much, and I'll see you in my next video.